Hi, and welcome to our last level 3 differentiation video. We're going to continue our second part of differentiation from first principles. This is quite nice that we finished with this video. I did warn you before, this is probably the very first video we should have had in the series, but it's quite fitting we're going to make it the last, because at the end of it, I hope you'll see the power behind what we've just done. All right, quick reminder that differentiation turns functions into gradient functions. Please make sure you've watched the limits videos on 24a or 24b, or you understand what limits are before we proceed. All right, well, here's the gradient rule that we derived from the last video, and we're going to show you how this works. Here's all the working from the last video, just to ring a bell, but we're not going to go through this now. If you need to, go back and watch the last video. Right, we're going to differentiate y equal to 3x squared from first principles. We've only got the one example to look at. Just a reminder, the cheats way you've been doing for a couple of years now. To get the gradient, we take the 2, comes out the front, times it by the 3, and we take 1 off the power, and we end up with 6x to the power of 1. We don't need the power of 1, so it's just 6x. So that's how we've been doing it for a couple of years now. But in this video, we're going to show you why it's 6x and how we get it. Right, let's get into it. First of all, the function itself is 3x squared. Function fx is just y. Now, if I told you f bracket 10, you're going to take 10 and substitute that in for x and go 3 times 10 squared, which is 300. If I told you f1, you're going to substitute 1 in for the x, and you're going to get 3 times 1 squared, which is 3. What if I told you fp? You're going to substitute p in for x and go 3 times p squared, which is 3p squared. Now, what if I told you f bracket x plus 1? You need to substitute in x plus 1 into x and get 3 times x plus 1 all squared, which you'd write as 3 bracket x plus 1 bracket squared. Now, we're going to use that right now to get the next part of this. What is f bracket x plus h? Well, just what we just did. We're going to grab x plus h and substitute that into x and get 3 bracket x plus h all squared. Right, let's write down the gradient rule that we're going to use to get our gradient formula. Okay, let's look at this part here. This is what we're going to end up with, and let's show you how we get this. This f bracket x plus h, we just worked that out above here. That's 3 bracket x plus h all squared. So that becomes 3 bracket x plus h all squared. Now we're going to subtract f of x. F of x is what we just worked out up here, is the function. So that's 3x squared. And that's all divided by h. All right, what are we going to do next? Well, we're going to expand out the brackets. It's a quadratic, so we're going to get x squared plus 2xh plus h squared. And then we're going to multiply everything by the 3 out the front to get 3x squared plus 6xh plus 3h squared. And we've still got the minus 3x squared at the end. Right, the 3x squareds will cancel. And that leaves us with 6xh plus 3h squared all divided by h. Now here's the beautiful part of what we're about to do next. They both have an h in common, and so we're going to factorize out the h. You would have seen this in the limits video we looked at back in lessons 24a and 24b. And we're going to then cancel the h's to get a function which is 6x plus 3h. Now, I'm not sure if you know what's about to happen next and if you're getting excited, but what we're trying to do is work out what is the value of this function when h is 0. That's what the limit of h to 0 means. Now, we couldn't do it back here because we couldn't divide by 0 back here. But now we can put h to 0 because we're not dividing by h. So we're going to put h to 0 and go 6x plus 3 times 0, and that 3 times 0 cancels to give us 6x. How beautiful is that? Great. Thank you very much for watching these videos, and best of luck with your examination.